This is the fusion reactor I'm thinking about building one. This is the normal cold fusions. What they do is they just put positive and negative rod in a water bath and bring up the voltage. This is the normal cold fusion, how they do it. Now here's the thing, I'll show you. We have a two different kind of voltage, 12 volt and 300 volt, or you can use 250 volt DC. Now we have a one negative electrode and two positive. This negative electrode has 12 volts and 300 volts in one electrode. So the voltage has, because the cold fusion, the important is there's not enough hydrogen is making to create a fusion reactions. We need kind of a lot of hydrogens. So to do that, it is more important to use a lower voltage. We need amps. What is it? Amps. You need amps to create a hydrogen from water rather than using high voltage. So the negative and positive here, this electron will flow like this, but also in the flowing like this way too, because we have 300 volts here. So it'll create more hydrogen burst in the water. So now this container is a little different than this one here. The reason for that is it's about deuterium. I've seen many cold fusion reactor experiments, but this seems to be the best shape, because I don't know why, but using an electrode very near down here on the water, actually it gave a kind of a brightish white light. I've done many experiments like this one here, and you get a red light, a red or orange light. You know, that sucks. That's just, that the orange light is a hydrogen. That's only hydrogen. But this experiment, it gives you a white light. I don't know where this white light comes from, but it's doing something. Okay, and I'm possibly thinking that's probably a deuterium. Deuterium is like working something with hydrogen, and it gives off white light. So what is deuterium? Deuterium is a heavy water, and it actually exists in all kind of water, but it's just heavier. So it is heavier water, so it's probably somewhere down here, very somewhere like 5% of here. So that's what it is. So now this one is it says heat exchanger. So it's made of stainless steel plate. So stainless steel plate is like this, and the water gets hot, it transfers heat. So we have here a clean water tank, and you can take a shower or heat up your home or do something. Now, another thing about this is some hydrogens are not burned, and these hydrogen bubble actually goes up, all the bubble, and it will increase the pressure of this chamber, and eventually at a certain point it will blow up because the hydrogen gas is expanding. So to fix that, I had to use some pipe. Use just a simple method. These hydrogen gas the pressure will go up and it will go down, and let the hydrogen gas again burn again. So using this method, it's all intact. You never have to open this. It will never blow up or do something like that. The pressure is always contained in a low pressure. So this concept the important part is this one, 12 volt, and using high voltage and low voltage to create a fusion reactor. And there's a water somewhere around this much. Oh, I'm sorry, water around here. Thanks for watching the video.